To chemists, there are two important types of polymers: naturally occurring polymers, such as starch, and synthetic polymers that we make in the laboratory or in a manufacturing facility. Really important type of synthetic polymer is plastic. And plastic is just a term that means some material is moldable, but the plastic that we see in our everyday life, in bottles and toys and garbage bags, are all synthetic polymers. So just a reminder, polymers are made up of monomers, and monomers are individual molecules, and we have a graphic here of this link in a chain that would represent a monomer, and this monomer can polymerize, meaning it can form a bond with other monomers to form a polymer. So if we put a bunch of the monomers together, bond them together, we get a polymer, just like if we have a bunch of links and we put them together, we get a chain. So we're going to look at what the repeat unit of a polymer is. That depends on the monomer that is used to make the polymer. And we're also going to look at the process of forming monomers from, we're going to look at the process of making polymers from monomers, which is known as polymerization. The first type of polymerization we're going to look at is known as addition polymerization, and that always requires a chemical with a double bond. And we're going to look at the simplest polymer that's formed from the simplest possible monomer. The polymer is polyethylene and the monomer is ethylene. So poly means many, and here's our monomer. This is what we start with. This is what we link together to form our polymer. I want to point out something about this name, ethylene. That eth means we have two carbons, and this name ends in -ene, which means it is an alkene. And of course, we know that an alkene is a chemical that has a double bond. So this is our monomer, ethylene, two carbons and a double bond. So anytime we have a monomer or a molecule that has a double bond, it is possible to perform addition polymerization on it. And it's called addition because each molecule is added together. And basically what we need to translate that as is no atoms are taken away from the monomer and no atoms are added to the monomer. And that's going to be important when we try to identify the repeat unit. So let's look at this graphic right here that shows our monomer of ethylene. And then after polymerization, a little part of the polymer chain. So this polymer chain goes on for thousands of carbons. But we see that our ethylene has connected. Now, a couple things I want to point out. First, I want you to notice that our monomer has a double bond and our polymer only has single bonds. So in addition polymerization, that's what happens. Our double bond reacts and those electrons move and allow that monomer to link to other ethylenes, which then move their electrons to become single bonds. So that's the first thing. Addition polymerization starts with a double bond and the polymer has only single bonds. Now, connecting the carbons, I should say. Single bonds connecting the carbons. The other thing I want to point out is you're going to be expected to identify the repeat unit. And the repeat unit is basically just the monomer, and you do that by counting the atoms. So if we look at the atoms in our monomer, ethylene, there are 2 carbons and 4 hydrogens. So our repeat unit is going to contain 2 carbons and 4 hydrogens. So the next slide shows the repeat unit. 2 carbons, 4 hydrogens. And this N down here just means that the number of repeat units or the number of monomers that form bonds is actually pretty variable, and it's also really, really large. So these polymers are just long chains that go on for thousands and thousands of carbons.